Okay, we continue discussion on encoding scheme. So we have quite a few types of encoding scheme. First is NRZ, NRZL. Second is NRZI. What is the difference? NRZL, NRZI. So non-return 0, L, non-return 0, I. I is what? Okay. The third is a bipolar, AMI. Number 4 is pseudo ternary. Number 5 is Manchester. And number 6 is differential Manchester. So these are different encoding scheme that can be used to convert the digital data into digital signal. So all these scheme have different format, different outputs. Okay, so you need to go through this topic on yourself. Okay. Next is multiplexing and demultiplexing. We call it mux, demux. Okay, multiplexing, demultiplexing. So what is the multiplexing? Multiplexing is physical link and nodes are shared among user. Synchronous time division multiplexing, frequency division multiplexing. So these are common type of multiplexing. Okay, so for example, we have 3 lines, line 1, line 2, line 3, and at here we have 3 R1, R2, R3. Okay, in this link, this 3 line will be multiplexed into this single link. Okay, so why? In effect, it increases the number of communication channels so that more information can be transmitted. Okay, often in communication, it is necessary or desirable to transmit more than one voice or data simultaneously. So you need to send more than one data simultaneously. And number 3, an application may require multiple signals, or cost saving can be gained by using a single communication channel to send multiple information signal. So basically you have multiple you have more than one channel, but you want to send through single link, or you want to send more than one simultaneously. You need one more than one, like video, right? You have video, and you have the voice or the audio. So you need to send you need to send 2 type of data simultaneously. So you need to multiplex. Okay, so where are the multiplexing applications? A lot. So you can see this multiplexing application in telephone systems, telemetry, satellites, FM radio broadcasting, TV broadcasting, and so on and so forth. Would be prohibitively expensive or impossible without multiplexing. So all these type of application using multiplexing application. So these are common types of multiplexing. First is FDM. Second is TDM. Okay. Third is CDMA. Okay. What is FDM? FDM stand for Frequency Division Multiplexing. So used for analog information. Individual signal to be transmitted are assigned a different frequency within a common bandwidth. So that is the uh, brief description about this FDM. Individual signal to be transmitted are assigned different frequency. So here, see the word frequency. They call frequency division multiplexing. Okay. So the second is TDM, time division multiplexing. Now you have time here. Used for digital information. This time, this is digital. For frequency is for analog. Okay. So time division is for digital information. Multiple signals are transmitted in different time slot. Okay, different time slots on a single channel. Okay, so time division multiplexing (TDM) for digital information where multiple signals are transmitted in different time slots on single channel or single link. So TDM also found in many analog applications because the process of A to D, analog to digital, and D to A, digital to analog conversion are so common. Okay. Okay. Third is CDM, Code Division Multiple Access, CDMA. Okay. So CDMA is widely used in cell phone, in telephone system, allow many cell phone subscriber to use a common bandwidth at the same time. Use spread spectrum. Okay, so this is for CDMA is for telephone system, and it is not covered in this topic, meaning that we will not go down further lah detail for this CDMA topic. Okay, this is common types of multiplexing, TDM, FDM and TDM. So what are the difference? So this is based on frequency. This is time. Okay, so you can see this chart. Y is frequency. This vertical axis is frequency and time. Vertical is frequency and horizontal is time. So same for this signal. But for FDM, the signal are divided in terms of frequency. Yeah, okay. Where in TDM, the signal are divided in terms of time. Okay. So that is the difference. Okay, we see the application. So for frequency division multiplexing, so you have like 4 devices. So connected to this multiplexer. Okay. So for channel 1, it use for this computer, it use the frequency range from 2000 to 4000 Hertz. For device number 2, so this is number 1, this is number 2, this is number 3, and this is number 4. So for device number 2, the signal from this device will be transmitted in the range of frequency from 4000 to 6000. Device number 3 from 6000 to 8000. Device number 4 from 8000 to 10,000 Hertz. So that are the way it divide the channel, okay? Divide the frequency. So they call it frequency division multiplexing. All right. So frequency are used. Frequencies used are example frequencies. So these are the example lah. So you can see that how they divide the frequency for each of these device or computer. Okay, so example, cable TV. Example, cable TV. Coaxial cable has a bandwidth of approximately 500 MHz. Individual television channel require about 6 MHz of bandwidth for transmission. How many channel it will carry? So, channel. So, macam mana ni? So, you boleh selesaikan lah. 500 divided by 6 MHz. Ni MHz. So, answer is so basically it can carry about 83 channels by calculation. Example 2, 5 channels each with 100 kHz bandwidth are to be multiplexed together. What is the minimum bandwidth of the link if there is a need for a guard band of 10 kHz between the channels to prevent interference? Okay. Solution, for 5 channels, we need at least 4 guard bands. This means that the required bandwidth is at least 5 multiplied by 100 kHz. This is for the channel. And 4 for the guard band. 4 of 10 kHz. So total is 540 kHz. Okay, so this answer is shown in the picture below. So you have this each of the channel 100 kHz. Okay, so what is this? EV. 5 channels. Let's say this is a radio. 5 radio channels. Okay, so each channel occupy 100 kHz. So you have 100, 500. So each of this channel is separated by 10 kHz. They call it guard band. Or sometimes they call it what is this? Call it guard band of 10 kHz. So you have 10 here, 10 here, 10 here, 10 here. So 10, 40, 500 plus 40. So total altogether, you need 540 kHz for question number 2. Okay. So next is TDM. So any question about FDM? Okay, so for other application for this, you might think of TV, TV channel 1, channel 2, channel 3. They have different frequency, right? Your TV. So that is example of frequency division multiplexing as well. Okay. Next is TDM. In time division multiplexing, each signal occupies the entire band of the channel. Each signal is transmitted for only a brief period of time. TDM can be used with both digital and analog signal. So in this case, signal 1, signal 2, signal 3, signal 4. So it has portion of that signal. So then it will repeat again, signal 1, signal 2, signal 3, signal 4. Okay, so this in this example, let's say it has 4 devices, 1, 2, 3, 4. 1, 2, 3, and 4. So the signal from this, so part of this signal dia ambil kat sini, kat sini. 1, 2, 3, 4. Then repeat again. 1, 2, 3, 4. Then repeat again. 1, 2, 3, 4. Okay, time slots are grouped into frame. So a frame consists of one complete cycle of time slot. So this is one frame. This is another frame. And this is another frame. So white, pink, yellow. A frame consists of one complete cycle of time slot. So satu frame ada semua cycle, complete cycle of semua ni. 1, 2, 3, 4. Okay. So one frame. Including one or more slot dedicated to each sending devices. Okay. So there is time division multiplexing. Okay. Time division kita ada synchronous and asynchronous. Or synchronous or not synchronous TDM. So what is the difference between synchronous and not synchronous or asynchronous TDM? Synchronous TDM, the multiplexer allocates exactly the same time slot to each device at all times. Macam atas tu lah. So dia ada slot dia, time slot dia ada ikut jumlah device. Whether or not a device has anything to transmit. Capacity is waste to simplify hardware implementation. So setiap device ada time slot dia. So tapi ada masalah dia lah. Masalah dia kalau device tu, sender tu tak ada, has nothing to send, then the slot is waste. Okay, the slot is waste. So for asynchronous TDM, each slot in the frame is not dedicated to the fixed device. The number of slot is a frame. Number of slot in a frame is not necessarily equal to the number of input device. More than one slot in a frame can be allocated for an input device. So they just define the number of a slot in the frame, tapi not necessarily equal to the number of input device. Okay. So for example, so this is the example for synchronous and asynchronous. So we can see this example, the difference between synchronous and asynchronous. So in synchronous TDM, you can see that it has 4 input device. We call it 4 device. Okay, 1, 2, 3, 4. So 4 device. This device has 4 input. Okay, the second device only have 2 input. The third device have only 1. And the fourth device, it have 3. Okay, 4, 2, 1, 3. But because the frame is allocated for the slot in the frame is allocated for each of these device. So in frame number 1, this one, the first input of each device, you can see, you can see that A, B, C, D. See, A, B, C, D. So the first input from all the device have the first input, right? So that each slot in the frame 1 being occupied, semua ada. Okay, for the second frame, input number 1 has input, B has, but C there is no input. Okay, however the frame, so the frame write A, B, D. So C there is no. So this is what we call waste of the slot in the frame. So this is what is called waste of slot. So the same happen for the rest. You can see the rest. The third input, only first and fourth have the input. The second and third doesn't have any input. So, but the slot still allocated. Okay. So this is what happened. For the asynchronous TDM, the slot and the number it is different. So the input is the same, 1, 2, 3, 4, and the input one have 4 inputs. Uh, number 2 have 2 input, number 3 have C, have 1 input, and number 4 have 3 input. Okay, so you can see that in this asynchronous TDM, it is different. Now, all frame will be occupied. 1, 2, 3, 1, 2, 3. There is no empty slot. Okay, but the frame being assigned the number of the input device. This is A for 1, B for 2, C for 3. The frame number 2 start from device number 4. Okay, D 4, and then again A, D, because B and C doesn't. Sorry, okay, B here. A, D. This is frame input number 3 already. Yeah? A, D. Because even there is no input here, so there is no empty slot. Okay. So, however, in the demultiplexing process, okay, the demultiplexer still can produce the signal for the device as it is in the input. Okay. So that is the difference between asynchronous TDM and synchronous TDM. Okay, here is another example you can see. So here A1, C1 for this is what? For synchronous. This is another example. There is a empty slot because there is empty slot here. A frame can consist of multiple units. Unit can consist of one bit or multiple bits. In synchronous TDM, it is possible to have empty unit or empty slot. Okay. So multiplexing, demultiplexing. So when you have synchronization, so you will be able to produce the input, the output similar to the input with this synchronization. Okay. For asynchronous TDM, synchronous TDM does not guarantee that the full capacity of a link is used because of that empty slot. Because the time slot are pre-assigned and fixed whenever a connected device is not transmitting, the corresponding slot is empty. Asynchronous time division multiplexing, on the other hand, or they call it statistical TDM, is designed to avoid this kind of waste, empty slot. Like synchronous TDM, asynchronous TDMs allow a number of lower speed input lines to be multiplexed to a single higher speed line. However, in asynchronous TDM, the total speed of the input lines can be greater than the capacity of the link. Okay. Some more asynchronous TDM in asynchronous system. If you have n input lines, the frame contains no more than m slots. With m less than n. M less than n, or n bigger than m. The number of time slot in asynchronous TDM frame m is based on statistical analysis of the number of input lines that are likely to be transmitting at any given time. In this case, any slot is available to any of the attached input lines that has data to send. Okay. Examples of asynchronous TDM. Case 1, only 3 lines in data. In this case, 1, 2, 3. Line number 1, line number 3, and line number 5. Okay. So here you have A1, C3, E5. A1, C3, E5. A1, C3, E5. Okay. Case number 2, only 4 lines in data. Line number 1, line number 3, line number 4, line number 5. So A1, C3, D4, A1, C3, D4, E5, A1, C3, E5, A1, C3. Okay. In this case, only 4 lines sending data. Okay. Case 3, all data, all lines here having the data. Okay. So addressing and overhead. In asynchronous TDM, each time slot must carry an address telling the demultiplexer how to direct the data. This address for local use only is attached by the multiplexer and discarded by the demultiplexer once it has been read. Asynchronous TDM is efficient only when the size of the time slot keep relatively large. Okay. The last topic, data switching principle and reliability. So this is switching strategies, circuit switching, packet switching, message switching. Okay, there are 3 types of switching strategies. Circuit switching, carry bit streams. Establish a dedicated circuit link reserved for use by communication channel, send receive bit stream at constant rate. Example, original telephone network. Circuit switching. The second is packet switching, store and forward message, operate on discrete block and data, utilize resources according to traffic demand, send receive message at variable rate. Example, internet. And the third one is message switching, store and forward message. No need to establish a dedicated path between stations. When a station sends a message, the destination address is appended to the message. Each node receives the entire message. Example, LAN, local area network. LAN. Switching method in computer network. For data transfer, different types of switching method are available. So that those type of switching, we call it circuit switch network, message switch network, datagram networks, virtual circuit network. Switch network can divide it into 3: circuit switch, packet switch, and message. So for packet switch, there are 2: datagram and virtual circuit network. Okay, so you can read about the circuit switching here. Circuit switching, packet switching. Packet switching method use 2 routing datagram and virtual circuit packet. Packet switching method use 2 routing methods. Okay, packet switching method. Message switching. Okay, that's all. Okay, so for that, we finish our second chapter. Okay, so you might read yourself the last part of this, which is about switching network. Okay, you have circuit switch network, packet switch network, and message switch network. 1, 2. Okay, so you need to read further about this using these notes, and also you can read somewhere else, other source of reference. So that's all for today. That is the end of our second chapter. So here there are reference book. Okay, you might look for this book online. If you want, you can contact me. I think I have some of this book. Okay, so that's all. Hopefully you can understand, you can appreciate what we have discussed, and you can write some your own notes to show that you have some understanding. I will come out with maybe exercises or quiz after you have finished this topic. Uh, we might cover some more chapters for test one. So I need to finalize what will cover in test one, and then I will let you know. Okay, that's all. Thank you very much. Thank you very much for your attention for this video. Make sure you uh, don't forget to subscribe to my channel, and fill up the Google form asynchronous class. Okay, so that's all. Thank you very much. Bye bye.